we're going to look at a method of factoring that's known as factoring by grouping, which is going to be useful for some other factoring techniques that we'll talk about in another video. Before we start, it's going to help to get some review of some other factoring examples that will be related to what we talk about. So here we have something that's two terms. We're going to factor x times the quantity x minus 4 plus 6 times the same quantity x minus 4. Now factoring, our goal is to look for things that are in common to both terms. And usually it's something like x or x squared or maybe a 24x or something like that. But in this case, notice that we have an x minus 4 factor in both. And so what you can kind of do from time to time is you can kind of say, well, let's factor that out and let's just completely ignore the x minus 4's. What's left over is an x plus 6. So our answer is going to be x plus 6 times the x minus 4. Okay, I had it backwards from what I said there, but x minus 4 times x plus 6. We'll do another one just like that. So here we have 4a times the quantity a squared plus 7 plus 9 times the quantity a squared plus 7. Again, the a squared plus 7 here is in both terms, and so we're going to factor that out. Then we look in each term and say what remains. Well, after we've factored out the a squared plus 7, we have 4a left and 9 left in the other term. So here I have a squared plus 7 times the quantity 4a plus 9. Let's go over some techniques. As to how we will do this. The objective is going to be to factor an expression that has 4 terms. The way we do this is we're going to separate the 4 terms into 2 different pairs. Each pair we're going to factor out any common factors. Okay, so I'll have 2 groups of 2 terms. We'll factor out common factors within those. Within each pair, what you may end up having is some common binomial, that's something that has 2 terms, that will be able to be factored out later on. What if the binomials aren't equal? Well, there are a couple of things we can do. First, you want to look to see if they're off by a sign. If they're off just by a sign, like one goes a minus 4 and the other one goes 4 minus a, then we want to factor a negative 1 out of one of them, and that will switch it the way we want it to go. The other thing we can do is, if they don't look anything alike, try to rearrange the terms and then do the whole process over again by factoring things out, and that usually does the trick. So let's look at our first example. We want to factor x cubed plus 4x squared plus 2x plus 8. Now we're going to group them. There are lots of ways we can group them, but it's kind of nice just to say, well, let's group the first 2 guys together, let's group the second 2 guys together. Okay, and that's what we've done. All I've done is inserted some parentheses to help us organize our thoughts. Now we look for common factors. Look for common factors within each of the parentheses. So in the first ones, I see an x squared that I could factor out from both terms. In the second one, I see a 2 that is in common with both of those. Factoring out the x squared, we end up with x plus 4. Factoring out the 2 from the second 2, we end up with 2 times the quantity x plus 4. And we're excited because we have x plus 4 in both of those terms, which we can now factor it out very much like the examples that we did at the beginning. So we have our x plus 4 that we factored from these 2 terms, and then we look to see what was left over, and we had an x squared, so there's our x squared plus 2, plus 2. Okay, let's look at another example. So we've got b cubed plus 27 minus 9b squared minus 3b. So we'll try this strategy we did before. We're going to group the first 2 terms together, group the second 2 terms together. Again, I just did this by inserting some parentheses, but I noticed that I kind of snuck the minus sign into the parentheses there. Now we look to see what each has in common. So we look at b cubed plus 27. I don't see any b in common to both terms, and there's no number, so I think that's pretty much as it is. And then we look at this guy, negative 9b squared minus 3b. Now that has definitely a 3 in it, and maybe I could even pull out a negative as well, because these 2 are both positive, both of these are negative. It also has a b in both terms. So when we do this, we end up with, that one didn't work too well, did it? No. So since that didn't work too well, I didn't look far enough ahead in my notes here, since that didn't work too well, we needed to rearrange things, because when I factored out the 3b, negative 3b from there, I would end up with a b term there, and there would be no b cubed. So this wouldn't have a b cubed term in it. So that was what we needed to do. Okay, so instead what we're going to do is we're going to rearrange. Now it doesn't matter how we rearrange them. You might rearrange them and then say, wow, that didn't work, and let's rearrange them again. But what I did was I took the b cubed and the 9b squared and put them together in the first pair. Then I took and I just rearranged their order, the minus 3b down there and the 27 over here. So I still have b cubed plus 27 minus 9b squared minus 3b. Now let's see what they have in common. In the first two terms I have a b squared. See that? We've got b cubed and a b squared, so we can factor out b squared. In the second two terms I have a negative, or a 3 in both of them. Now here's something that you can look at kind of as a problem-solving strategy to help you out. Notice this goes plus minus, this goes minus plus. See that? Plus, minus, minus, plus. So factor out a negative 3 instead of just a 3. And when you do this, you get the b squared, leaving us with a b minus 9. Factoring out negative 3, that would leave us with just b there. Now this is a positive, so when I factor out a negative 3, I'll end up with a negative 9. If you don't feel comfortable with that, once you're done with it, if it doesn't feel right, just redistribute. Minus 3b minus 3 times minus 9 is plus 27, so that did work out right. And now we see the magic. We've got the minus b minus 9 in both of those. We can factor that out. And when we do that, we have a b minus 9 at the back end. Both of those came from that. And then on the front, we have a b squared that goes there, minus 3 that goes there. Now, you might ask, can I factor b squared minus 3? And it turns out there will be some ways to factor it, but you have to introduce square roots. We're not going to go into that in this particular example. So our fourth example, we're going to look at another one. We've got 5x squared minus 20x plus 3x minus 12. Again, we'll group them. Take the first two terms together, take the last two terms together, see what they have in common. The first has a 5. The second has a 20. So we could factor out a 5 from that, and then this has an x and that has an x. So I think we can get a 5x out of this guy. Okay? From this one, we could factor out a 3 because we have a 3 in common with the 3x and the 12. When we do that, 5x, that would leave us with, well, 5x times what gives us 5x squared? 5x times x. 5x times what gives us negative 20x? 5x times negative 4. Factoring the 3 out, 3x divided by 3 just gives us the x. 12 divided by 3 gives us the 4. Now we want to see, are our terms, are our binomials the same? And yes, they are. So I can factor those out. When I factor those out, we get the x minus 4 from both of those. When I factored in x minus 4 from the first term, we ended up with a 5x. When I factored it from the second term, we're left with a plus 3. And for our final example, I didn't point this out in the last one, but I am going to point it out here. You'll notice that in these last two examples, we had x squared terms, and then in the middle, you have these x terms, and you would say, well, why did we do two different ones? Why didn't we just combine those two together to get minus 22x? And the reason we did that is because it's going to help us prepare for a method for factoring these quadratics later on. So I broke them out just to get us some more practice like that. This is an old, boring step, but yes, you're going to pair the first two terms, pair the last two terms, again, because that's minus. Let's absorb that inside the parentheses. Then we want to see what can we factor out. Well, in the first we have an 8 and a 12. The greatest common factor of those two is a 4. And then I have x squared and x, so I could factor a 4x from the first one. And again, notice the order of the signs. That goes plus, minus. This goes minus, plus. Since they're opposite, it might be helpful to factor out something that's a negative. And then we look to see what we have in common. 10 and 15 have the largest common factor of 5. So we'll factor out a 5 from that guy. When I do this, we end up with the 4x that's out here. 4x times 2x is going to give me the 8x squared. 4x times what gives us minus 12x? Well, it'll be multiplied by negative 3. Again, remember we factored out a minus 5 over here. When I factor out minus 5, that's going to leave us with positive 2x. And because it was positive 15, I'm dividing by negative 5, which is going to leave us with negative 3. And once again, we're excited because the binomials match. And so we can factor out the 2x minus 3. When we factor out the 2x minus 3, there it is. And what's left? Well, we have a 4x and a minus 5, which we put inside over here.